Okay, so it seems like we're live. So we're gonna do like a short stream here in which we use JavaScript. Okay, so this is we're gonna modify this app. I think I'll come back to this app, but we're not gonna use this app right now. Anyway, this is a neural net, and it is the so we have a neural net with 3 floating point outputs, and we're interpreting them as colors. And each pixel is a grid point for like a random plane in the 5-dimensional space of the neural net, like the input points. And then the thing on the right is a second neural net trying to match the first one, and it looks like it's having problems with it. But what we wanted to do in this stream is just have like one image, and we're going to have this grid, like just this random 2-dimensional plane in the 5-dimensional space, and we just want to animate like moving the grid like within the space. So yeah. So it shouldn't be too hard to accomplish here. So let's go to the code. So we're going to get rid of this canvas, and we only need one canvas, and we only need one canvas, and our grid size, I guess, for setting up will be like 10. We only need one neural net. Okay, so this is setting up the grid. We need all of this. And okay, so X is the grid points. Get rid of that. Get rid of that. We do need the predict. This, okay, this is still like at initialization. So this draws to the screen, and then this is involved with training, which we're not training. Okay, so then we call it the animate frame, and I think we just need to pass the neural net itself and the grid. And yeah, so that's called once. So we come down here, and so we're not training anymore. Yeah, okay, so instead of training, we need to update the grid and then rerun the prediction and then redraw. So it should be pretty easy. So I just need to come up with the code to update the grid. So I think that's going to work by just every point in the grid, we're just going to add like the same vector, because we're just moving in the input space. So I think, let me see what the grid actually is I should also call the grid. I mean, X is the grid. Okay, so let's just see what the shape of X is. Because I don't know. Okay, so it's 100 by 5. And I'm going to have a single vector, like 5 by 1, that I want to add. Also, animate training, that needs to change. So 132, I should say 0. Okay, so yes, I need to use broadcasting. Do I have it in here? No, do I have X? No. Okay, so yeah, alright, so I need to figure out the broadcasting, how that's gonna work. So, X, so the grid points are this random tensor of shape 100 by 5. And I just want to add to every one of those 100 5-dimensional vectors, like a new vector. So I think if the new vector is of shape 1 by 5, that should work. Maybe. Yeah, I think that works. I don't really know, but we'll accept that as working. So that's all we need to do in the code is, I think we need to generate like the direction vector that we're moving. So that will just be we'll use a normal distribution, I guess. I don't think it matters. So that'll just be like 1 by 5. And I think we want like a very small standard deviation, because I think that gives it like a small radius. I gotta figure out what the call signature is. And shape mean, okay. So like 0 and then like 0.1 or something. So I'll just make that 0. That's the mean. And then the standard deviation 0.1. That doesn't really matter. And we're going to pass the direction vector to the animation step. And then we're just going to add at every step the vector. And I assume at some point we're going to like go out of range or something, but let's see. So I need to do also all of this needs to be moved over. That's annoying. Okay, so x tf add x. I think you just add the direction directly because the direction is 1 by 5. So yeah, so I think that's it. So that should be like the entire thing. So that should just work. So this should be like a cool animation. G1 animate training. that should be G0. Okay, it works. So now let's do more points. And like make that smaller or something. 2 more points. And is this working? I can't tell if it's doing anything or not. Oh yeah, I was going to is this doing anything? I can't tell. Maybe make the frame rate higher. So wait like 30 milliseconds. Okay, yeah, it is kind of moving. Yeah, it would be it would be good to see what the actual maximum and minimum grid points are, like, so we know what range in the grid we're in. But I mean, this is working. Yeah, let me see if I can print the like upper left value of the grid. I think I can use this output P and say out, or let's see, am I capturing that anywhere? Like, yeah, okay, I need to get that. Okay, so the output div equals get element, and what did I call it? Output underscore P. Okay, and then I think you just say like output div dot inner HTML equals in 0 outs 0. So this will print the entire vector, hopefully, for the upper left corner. In theory, and it should print it like right here. Whoa. Which it does. So, yeah. So, okay, so yeah, we just have this grid of points, and we're moving in this direction, and like a weird direction in the input space. Yeah, let me also output the, like, oh, this is the output value. That's not what I meant. I wanted to print the, not the output, but the input. So, okay, so this is like the upper left corner of the grid. Undefined. Why? Oh, because you didn't say array. Wow. That was some weak sauce. Okay, yeah, so... Yeah, I think we're kind of like, yeah, these numbers are too large. Yeah, I wanted them, like, I think you want to stay between -1 and 1, maybe? So, yeah, they're way too large. So, also, I don't know why this is all of a sudden cutting off. That's not cool. Okay, so anyway, the direction needs to be much smaller. Scale that down. Okay, all of a sudden we're being cut off. I don't know why. Alright, don't do that. That didn't work out. So I guess, okay, well, I mean, all of a sudden this seems like it stopped working. It was working a second ago. Okay, don't multiply the direction. Did this stop working? No, this is doing something. I mean, I guess, like, it seems like what we're learning here is that the, you know, if you visualize the input space of a very small neural net, by the way, like, our neural net is 8 hidden units, 5 input units, so it's a single layer neural net. I guess, like, you can literally, this is one decision boundary, 1, 2, 3, 4, 5, like, you can almost, I guess, see the decision boundaries for each of the units. So anyway, I mean, like, what we're learning here, right, is that the input space of a very small neural net, if you visualize it by taking a very small grid and just moving that grid, like, in the input space, what you get is a bunch of lines, which I think is basically what you would expect. Let's do, like, a bigger... Let's do a more hidden layers. Okay, so now we have a bigger neural net. And I mean, this one doesn't do much. I wonder if I could have like a bouncing effect. So like if my grid, I guess like if any point in my grid hits, you know, like plus or minus 1, then like just reverse the direction. So that way we're always like, we're not just going off into infinity. Like we're just bouncing around within the input space. I mean, this one's kind of cool, but what if I make it go faster also? I mean, yeah, it's like a bunch of blurry lines. I guess that's what you would expect. Yeah, so let me try to implement the bounce effect. So yeah, I think the way we'll implement the bounce effect is, well, yeah. That one's cool. Right? I mean, this one's cool. Yeah, I mean, it's, you know, it's just a bunch of lines. And they intersect in various ways. Who knew that the input space of a neural net would be so boring? And yet, if you have like a GAN, then it's cool. Or like a neural radiance field. So anyway, yeah, I'm gonna try to do the bounce effect. So I'm basically gonna say if Can I... So I want the upper left corner of my grid, which is X. So can I say norm of the upper left corner, or just the first point? Is that cool? We will find out. No, that's not cool. Right. But I just want the norm of the first thing. Huh. Oh god. I just want the norm of like the first element. But that doesn't look like it's gonna work. So yeah, I don't know how to do this. Okay, what if I just compute the max of the entire thing? Since it doesn't want to do the norm. Okay. Whoa, this one's cool. Some particular, okay, so can we do comparisons? Is there like greater than? No? Greater than? Is there a way to do comparisons? Yes. Okay. Okay, so if the max, so we're gonna do a thing where if the max I mean, really, you should do the absolute value, but I don't know how to do that, so I'm just going to say, or the min, well, yeah, but you still need the max, okay. Okay, so if the max is greater, hopefully I can just put in a number, 1.0, or, less if the min is less than -1, then we want to multiply the direction by -1. I mean, tf multiply direction -1.0. So that should give like a bouncing effect or something. I literally have no idea what it's going to do. So we're going to find out. Well, yeah, I guess it's oscillating. So maybe you want, or maybe, what if we say, I mean, I think instead of multiplying by -1, you want to take, like, I mean, you want to, like, have it bounce. Instead of going directly backwards. Yeah. But I don't know how to implement a bounce, because you have to have, like, the angle. I mean, we could give it a larger... I mean, maybe just give it a completely new direction. We just give it, like, a completely new direction, maybe? Yeah, I can't tell what this is doing. Yeah, I think maybe I need to work on, like, the scale of my numbers, because my grid is... Yeah, it depends on the norm. Yeah, we might want to make those, like, smaller. Or can I say here, like, scale by 0.1? I think that's probably gonna break. Yeah. Alright, never mind. Yeah, we're pretty much bouncing constantly. Yeah. So yeah, I don't know what to do about that. Yeah, so the bounce thing doesn't really work, I guess. But anyway, this is what we set out to accomplish, is this animation. So we're just moving through the input space of like a neural net. And it turns out that the input space of a neural net is a bunch of lines. I mean, I guess like at least for a densely connected neural net or something, it's a bunch of lines. So yeah, I guess I'll call that a stream there. I think yeah, I think like next stream I'll go back to the original project of like watching one neural net converge on a different neural net, just to see how that goes. Okay, thanks for watching.